All right, so from 2.11, there was one type we didn't get to at the end of last class. So just a quick review of how you handle any absolute value problem plus this one extra that we hadn't gotten to. And the idea is this. There's three possible things that could happen when you have a single absolute value equation, with just one set of absolute value bars. And that is that you have some expression, and I use a big X to mean the expression. That expression could be as simple as just a little x, or a 2x, or a 2x plus 9. Any expression. It could be a fraction, decimal, any kind of expression. So this big X just stands for some expression. We don't care how complex or simple it is. And it's equal to a number, a constant. And it's either equal to a constant that's negative, it's equal to a constant, or 0, or it's equal to a positive constant. That's the only choices for numbers, for a constant, negative, 0, negative, or positive. Okay? Now, if your absolute value is equal to a negative constant, what do you have?
No solution.
No solution, right. It's impossible. No matter what happens inside these absolute value bars, doesn't matter. It's going to spit out a positive, because the absolute value of anything is positive, because distance is positive. That's all absolute value is distance. So this is impossible. Okay? So in this case, you would just have, don't do any other work, just no solution. Done. Okay? Or no solution. Okay? Now, can absolute value be equal to 0? Yeah. It just means whatever your anchor point is, you're standing at it, and you decide not to move left or right. You just stay where you are. So how many solutions will you have in this case? No. How many? Just one. Right. Now, if you want to still think of it, just so it doesn't have to think of it like a different rule, it still is, it's isolated, so you split. You drop the bars, and you split it into 0 to the left, 0 units to the left, and 0 units to the right. It's just that, that's not a thing. Okay? It's not a different rule than this one. It's just not a thing. So you end up with one solution. And here, you've got a positive number. Distance is positive, a certain number of units. You split that into whatever the expression is, drop the bars, and it's that many units to the left, and the other one you solve is that many units to the right. You split it into two linears. You can solve linears using your general strategy. Okay. And in this case, you get two solutions. Now, the key is, and this is the question I always get the most when somebody's struggling with a problem, I get the Ask My Instructor, the questions is very common, very important. You cannot get the right answer unless you have isolated it first. You must isolate the AV expression first. It must be all alone on the left or the right. It doesn't matter which side it's on. But our eyes likes to see it on the left. Okay? That's a must. And then you drop the AV bars and split the AV equation. And I'm going to abbreviate equation as EQN. If ever I do abbreviations, you're not sure what I'm writing, please speak up. So you split the AV equation into two linear equations. So basically the idea is isolate first. So isolate and then drop the bars and split them into two linears. So isolate, then drop and split. And it's only after you split that you deal with fractions, etc. Okay? Because after you split, that's when you have two linears, and that's when you use your linear general strategy, such as killing fractions and decimals. Okay? But don't do that until you've dropped and split. And don't drop and split until you've isolated. All this order matters. Is that okay? Does that make sense?
Maybe I didn't hear. I was just noting and didn't hear.
Okay.
On the last set,
the last, up here?
It's like, per se,
Mm-hmm.
if it's a letter, that's when it has two solutions? Because over here with the O, when there's a we can't count the negative.
Right, because that's 0, okay? So,
Zero, sorry.
yeah, it's a 0. So you split it into -0, +0. I'm just showing it's not a different rule than this one. It's just that we throw that out because there is no -0.
Right.
Okay. Here, it's not thinking a letter. C stands for constant, so it's some number.
Oh, okay.
Okay. And so if your number is negative, whatever that number is, we just say C for constant. So it's some number. If it's a negative number, no solution. If it's a positive number, you're going to get two solutions.
Right.
Solution to the left, solution to the right.
Okay, so C means.
C means constant. Yeah, it's just a number. Yeah.
Okay.
Yeah. Mhm. Okay. Other questions? Now, if you moving ahead in the homework, if you've seen, like I said, we kind of left off at the end of last class, didn't get to this one, but there's one other type that you may see. Okay. And so that, are we okay with this? Okay. So that type looks like this. That's when you have two absolute value expressions. So you've got an absolute value expression. I'll just do big X, whatever the expression looks like. Make sure if you came out, you sign in next to your name, and you got the handouts and a ruler. Is equal to another, I'll call this one Y, big Y, just different than the first one. Okay. Now you're not going to, in this case, when you see one of these, you're not going to have anything outside these AV bars. So you don't have to worry about isolating. Okay. But it's still the same idea as you've got one solution to the left and one solution to the right. Okay. So you're still going to split it into two linears. Don't have to worry about isolating. You're going to split it into two linears. So this is how it splits. I always put because of the way the number line works, I always put the negative version first because that's left on the number line, and then that's just how I consistently do it. It doesn't matter which one you saw first. What's very important is that for the first one you saw is you drop the bars, and you go this expression, instead of just a plain number, just a number, a C, it's an entire expression. So you go this expression to the left. Instead of -C, it's -Y. Okay. Now, watch how I put that Y. That Y stands for whatever expression is in here. Now, note how I put it in parentheses. I dropped the bars. Why would I put it in parentheses, though?
Because the whole expression is negative.
Exactly, yeah.
There's the 1.
Yeah. So this expression might be like 2x plus 9. Well, not just the 2x is negative, but the 9 is too. You have to distribute that negative sign. Okay? So this is the biggest sticking point with this type of problem. Is you've got to remember, for the negative version, you just drop the bars on the first one, it doesn't change, but the second one is negative, just like the C is negative, but since it's not just a plain number, it might be a longer expression, put it in parentheses, and distribute the negative sign. Okay? And then the other version, to the right, is just drop the bars, that doesn't change, on the left, just like before, and it's equal to positive C, or in this case, it's not a C, it's a whole expression, so it's equal to positive Y. Therefore, it doesn't need parentheses. Okay? So it's just like negative C and positive C, C to the left, C to the right, it's just expression to the left, expression to the right. The left-hand side, the X, stays the same. You just drop the bars, and on the second side, you drop the bars and make it a negative version and a positive version. Okay? So you're going to have two solutions. So let's say you've got, as an example, 2x plus 3 is equal to 3x minus 5, absolute value of both of them. Like I said, you're not going to have to worry about isolating these. There'll be nothing outside those bars, just an AV on the left, AV on the right. Okay? So you're ready to drop and split. So you drop the bars, 2x plus 3 is equal to this expression to the left. Remember, it's not just the 3x that's going to be negative, but it's also the -5 that's going to be negative, which makes it right. And this one, just drop the bars, and it's equal to the positive version of this expression. So you don't need parentheses, just drop all the bars. This is your -C, but in this case it's -Y, and your positive C, your positive Y. So before you solve this one, of course, you have to distribute. And like I said, stop me if I start doing these mental steps and you're not sure where I got, stop me and ask. I'll say them out loud. Okay? I'm going to move the 3x over to the left, So that's going to make a 5x over here. Add 3x to both sides. And I'm going to subtract 3 from both sides, making a 2 over here. I just did my addition property, both of them in one step, mentally. Added 3x to both sides and subtracted 3 from both sides. And divide both sides by 5. And here, of course, let's see, I'm going to subtract 2x from both sides, leaving just an x over here. And I'll add 5 to both sides, canceling it out there and making this an 8. Okay. I said my addition property mentally. Okay. Like I said, I'm not going to be writing those steps down every time, but do speak up. You're like, how did you get there? Okay. So this gives me my 2 solutions of 2/5 and 8. Okay. And of course, always check back in your original equation. I'm sorry? Oh, this one? This one here? Well, I did minus 2x on both sides, so that makes a positive x over here. And I had to add 5 to cancel it out here, so I added 5 here. Yeah. Yeah, your solutions might be 2 positives, 2 negatives, or a mix. The solutions, remember, it doesn't matter whether they're positive or negative. Okay? Because all these are the x's that are inside here. What matters is what gets spit out of an absolute value, which has to be positive once it's spit out. But the x's could be positive or negative, it doesn't matter. So now you've got your 2 linears you're solving. Now there are cases too, you'll see where if you have the same coefficient of x, and either they're exactly the same or they're opposites, one's positive, one's negative, once you make your 2 equations, that means in one of them, the x is going to cancel out. So what happens when your variable cancels out? What do you end up with? When the variable's gone, do you still have a solution? You either have, you said no solution, or all real numbers. Yeah, once your variable cancels out, it depends on whether you have a true or a false statement. Okay? A true statement means any x will work, so all real numbers are good. A false statement means no matter what you plug in for x, you're going to get a bad solution. It won't satisfy, so that's no solution. So I'm going to leave that. I want you to try those last couple of problems on the homework, and you might see, you'll start to notice, hey, if the coefficients match, or even if they match but they're opposites, then I'm probably going to end up with no solution on one of these. That doesn't mean the whole problem has no solution. It means you just have to throw out one of the solutions, but you still have a good one. Okay. So take a look at that, try it. If you're confused by that, just send and ask my instructor. Okay. But just keep that in mind. You'll have 1 or 2 solutions depending on what happens once you drop the bars. But the setup is the same as with a number. Okay? It's just opposite expression and the expression as it is. Okay. Questions? Comfort level okay with that? When we, by the end of the semester, we're going to come back and do inequalities, not just linear inequalities, but absolute value inequalities too. As long as you're comfortable with the equations, the absolute value inequalities fall right into place. So a confidence with this now will make the end of the semester be an easy note to end on. Okay. Okay. Good. Any homework questions? Questions from last time? Anything before we barrel on into the next thing? Okay. All right. So we're jumping into graphing and then functions today. Graphing specifically today and functions on Thursday. In the calendar on my math lab, bring that back up. You'll see it, today's class is 8.1 and 8.4. And so it's putting it together. Really, I'm going to focus on 8.1 today, and that's the homework you see posted. Okay. 8.4 is going a little bit deeper into interpreting and understanding slope, and we're actually going to do that next Tuesday. Okay. So actually how I do this graphing stuff is actually a little different order than what you see in the book. I try and align it as much as possible so when you're reading the textbook or working ahead that it kind of matches, but I don't necessarily love the order that's in the book, so you'll see me sort of get off track that way. Today is sort of an overview and a review of graphing. It's a review of graphing if you came straight out of 308 or from math recently. If it's not comfortable so I'm hoping for most people this will be, I don't want to use the word boring, but just, it's review, like, okay, yeah, I got that, okay? If it's not, if you don't have that comfort and confidence level with it, then talk to me. Come to the open labs, make an appointment, talk to me. I'm also going to give some extra graphing practice for this weekend. It's optional. It's kind of like part of a practice test or a practice quiz. not part of your grade, but if you're not really comfortable with graphing equations, then you'll want to put in some extra work on that. Okay? So we're going to overview that today and all the basics about what a linear equation looks like and what it means, the difference between a single variable and a two variable, stuff we touched on last week. We're going to go deeper into slope, and you'll see this homework show up next week. Okay? And so today is a lot of what should be review-ish material. And on Thursday, just like last week, on Thursday, we go from what should be review-ish into what's brand new. Okay? And these functions are the basis of algebra. This is going to propel you into college algebra. Finishing homework 8.1 and then even better also reading ahead in 8.2 will make Thursday go a lot smoother. Okay? Because like I said, Thursday is new material. New as far as like was not covered in 308. Okay? So understanding functions, it really isn't anything that you haven't already been doing. We're just going to be defining it and talking about it in a different way, okay, in sort of a higher algebra concepts way. It's not necessarily a lot of new skills, but talking about them and defining them in a little bit different way. Yeah, and so we've got 2 weeks, this week and next week, before our first exam then on the 20th. Okay. All right, so back to we're jumping into 8.1. The homework I posted for 8.1, as much as possible, sort of covers what we're doing today as well. Like I said, it's kind of an overview, and I go a little sort of off book on it, but because I want to prepare you, I really want to prepare you for college algebra. That's the thing. And so when I do the 310 material, I, as much as possible, want to start planting those seeds and really start building that bridge to college algebra. So what you're doing in here makes sense, and it will make college algebra easier. Okay? That's the goal. All right. So, 8.1. Okay. All right. Get these, stay organized myself here. Okay. All right. So, I'm going to show some things overhead on the graphing website, which is free, and I'll post a link to it as well too. It's fun to play with and see how equations get affected. So I'm going to show some things. I'm going to start off, even though our focus is going to be on linear equations and linear functions, like I said, I want to start building those bridges, and also I'm going to start, because we've just been doing absolute value equations, I'm going to show you some absolute value functions and graphing. So don't worry about taking a lot of notes on this right now. It's more to sort of, like I said, plant those seeds. It's easier sometimes, I think, in the absolute value equations to see how the graph is moved and manipulated, how the equation talks to you. And so then we're going to apply that to our big focus, which is linear equations. Okay. So to start with, let's take an absolute value equation, a single variable equation. 2x, absolute value of 2x equals 3. So go ahead and solve that for x. It's already isolated, and also no fractions or anything, so pretty straightforward. So this is a single variable absolute value equation, and we got two solutions. And when we talked about solutions to single variable equations, what do those x's mean in relation to the related two variable equation?
Can you say that again?
So this has a related two variable equation, one that we can graph. So if we're just solving the single variable equation and we get our solutions, our 2x equals this and x equals that, how does that relate to the two variable equation that we can graph? What do those x's mean on that graph? The what? Right.
For the movement?
Not the movement. I think it touches the x. X.
X and Y intercept.
Right. Yeah. We're all putting it together. Good. Yeah. Specifically it's the x-intercepts. Okay. Not the y-intercepts. The x-intercepts. Okay. We are going to look at y-intercepts also for linear equations. But if it's x, it's an x-intercept. and that's where it crosses the x-axis on the graph. Okay? So it's where it moves across. That's what you're thinking. It was moved. Yeah, it's where it touches, it crosses, it moves across the x-axis. Okay. So let's take this equation, that 2x, absolute value of 2x equals 3, and as I had pointed out in your general strategy, this first part is about simplifying. But here, when you're solving, these addition properties and multiplication properties of equality are good whether you're solving a linear equation or whether you just want to change how an equation looks. Okay, so here on the general strategy, we're using them to solve a linear equation, but using those same properties, if you've got an equal sign, you can use the properties of equality. So instead of solving this, let's just use a property of equality to make it look different but not change its value. If we follow the property of equality, it's fair and its value won't change. Go ahead and move that 3 over to the left so that this is equal to 0. Exactly. So minus 3 on both sides. Okay, we're kind of unisolating it now. Now those can't be smushed together. You can't smush together something that's inside bars and something that's outside bars. So you got 2x, absolute value of minus 3 is equal to 0. Okay. Now, let's say that y is equal to 0. Or we could say 0 is equal to y. Okay? It's equivalent things to say. So this is our single variable absolute value equation. Okay? We can go back. If we were given this, we would just add 3 to both sides so it looked like that, and then we would solve it, and we get this. Okay? Here we're going in another direction. We moved everything over to the left so it's equal to 0, and now we're going to interchange. Instead of writing 0, we're going to write a y. Okay? And then just because it's easier for our eye to look at, we can just flip it over. So y equals 2x minus 3. Okay. So this is the single variable equation, okay, which you can solve for x. Okay. You're going to get 2 solutions. Okay. And this is the related 2 variable equation, which you can graph. And as I'll point out now, and this will come up again and again, the very definition of an x-intercept is where the graph is when y equals 0. Okay? So if you ever want to find the x-intercept of any equation, you plug in y equals 0. Okay? You're given a 2-variable equation of any family. You plug in y equals 0, solve for x, and you have found the x-intercepts. The definition of an x-intercept is when y equals 0. That's why these are the x-intercepts, because there is no y. Why is there no y? Well, there is a y. It's just that y equals 0. Okay? If we go ahead and move that 3 over, we can see, oh, okay, well, there's the 0. And if I just move it back and solve, I got the x-intercepts because I say, yeah, I want y to be 0. That way, when I solve for x, I have the x-intercepts. Or I can make sure that that 0, once I solve it for 0, I change it to a y, and now I have an xy equation I can graph. Okay? And that has infinite points. Just only 2 points that are on the x-intercept, and the rest are off the x-intercept. You can get infinite points. You plug in an x, you get a y. Plug in another x, get another y. Plug in another x, get another y. Infinite points make a graph. Okay? So these are related in that when you plug in specifically y equals 0, not anything else, but specifically y equals 0, and you solve for x, then you're going to find that special point or points that where that particular graph crosses the x-axis. Once you know those, you can start to visualize the graph. Okay, so let me switch over to the graph. And don't worry about writing this down. This is more to sort of visualize and see how the equations start to talk to you. Okay? Using that as an example too. But here's let's see where I start. So this is called Desmos, And like I said, I'll post a link to it. It's an online graphing calculator. It's free. And so you can put in any kind of equation. Unlike in a graphic calculator where you have to solve for y first and then enter, on here you can just enter the entire equation however it's written. It doesn't have to be solved for y. So that's pretty cool. You have to do a little less work to see it on here. All right, so first I'm going to put in what's called the parent. Okay? There's different families of what's called functions. Okay? We've worked with linear before, linear equations and graphing linear equations. Hopefully you have recently in the past. And that is called the linear family. Okay? Another family is the absolute value family. There's the quadratic family, and the cubic family, and the square root family. Okay? Each family has a parent. Okay? So here's the parent, the mother function of the absolute value family. So I would write it as y equals, and then this keyboard, you can bring the keyboard up and down here. Here's absolute value, and put in an x. And you can see that it's called the parent function because there's nothing else shifting it around, no other numbers, nothing else that's making it move. It's centered right there on the origin. And if you were to solve this, if you said if you solved this, if you said y equals 0, the absolute value of x equals 0. What would that make x? 0. So if y is 0, x is also 0. The only way to get y is 0 is if x is 0. Therefore, the x-intercept is 0, 0. It's right at the origin. Okay. Now, watch what happens. Y equals, and I'm just going to work with the parent one, and then I'll put in the one we just did. So what if we have y equals x, and then outside of the absolute value bars, I'm going to subtract 3. And what happens there? Now, can you relate what you're seeing here with what you see in this equation? It's the parent, y equals absolute value of x, but dropped 3 spaces. So what do you think would happen if I wrote y equals x square root of absolute value of x plus, oops, yeah, there we go, x, and then let's do plus 2. Yeah, up or down, right? So minus 3 dropped it, and plus 2 raised it. But notice that this minus 3 and plus 2 were both outside the absolute value bars. Okay? So that changed where your y-intercept is. Okay? The y-intercept was changed by this outside number. Okay? Nothing was bothering the x inside the absolute value bars. The entire function, the y equals, the entire function was either dropped 3 or the entire function was raised by 2.
Just the outside number.
Just the outside number, right. And we're going to see a similar thing. Like I said, it's kind of easier to see with the absolute value, but once you see that, then it becomes a little easier to see in the linear version of it. Because if you have an outside number, it's going to drop your line or raise your line on the y-axis. Now let me take away that plus 2. What happens if instead of changing the entire function, raising or dropping the entire function, I mess with the x?
Go left and
right. Now let's say I put in a minus 2. Is it going to move left or right?
right.
Huh?
Right.
Right? Into the positive side if I do minus 2?
Right.
Okay. And how many people think it'll move left? Huh? That seems logical, right? With the minus, here's the thing. And again, like I said, you don't have to worry. I'm planting seeds. Okay. When you're messing with the x, you've had this before, huh?
Yeah.
When you're messing with the x, it creates opposite math. Okay. The whole function, plus or minus the whole function, will raise it up for plus and down for minus. But when you're messing with the x, it's the opposite. Minus 2